Okay, I asked you guys to be working on part B for average rate of change, where we left off yesterday. So, did you guys have any luck? Part B says for f of x equals 3x squared minus 1, so you're given a function, and then in the interval is from x equals negative 5 to x equals 3. So what is that x equals negative 5 and x equals 3? Those are your a and b values, yes? I tend to make my smaller value a, my bigger value b, but in all honesty, it's not going to matter as long as you're consistent with what you use first and second. Okay? So what did you do with that a and b? You plugged them in. You have to find your f of a and f of b values. So we need to find f of negative 5 and f of 3. What do you get for f of negative 5? I'm hearing 74. Because negative 5 squared is positive 25, times 3 is 75, 75 minus 1 is 74. Don't let the calculator trick you. Okay, what about f of 3? 26. Sounds about right. Squared is 9, times 3 is 27, minus 1 is 26.
Oh, sorry. The reason why you tend to make your bigger number a is so that when you do the subtraction, or like when you do the f of b minus f of a, it's going to be like a easier solution.
Your denominator will at least be positive. If I make bigger minus smaller on b minus a, my denominator will at least be positive. Who knows about the numerator? And again, as I said, if you reverse it and you did these exactly backwards of me, it'll still work out to be the same. Kind of like slope. It doesn't matter. What'd you guys set up then? Okay, I hear 26 minus 74. And if we do 26 minus 74, then on bottom the order has to be 3 minus negative 5. 26 minus 74 is negative 48. Becomes 3 plus 5, which is 8. Negative 48 divided by 8 is negative 6. Okay, are we good there? Okay, let's try C. And what I will tell you, this number 78 in homework. Yes, it is only number 78, but I will also warn you, number 78 has multiple parts. Okay, I don't know if anyone looked at the homework last night. Like 8 parts. And what it is, it's 8 individual parts doing average rate of change. So if it has 8 parts, that means you have 8 average rate of change problems. Does that make sense? It's not like, okay, now you do A, and now B is asking you something about A. It's not a building type 8 parts. It's 8 individual average rate of change problems. Okay, so when you get to that, just an FYI. Kind of like A, B, C are 3 different problems here. It's A through whatever on 78. So that's, it looks like it's just a few short problems. 78 is a handful though. Okay. But at least it's, a handful of this. Okay. Did you guys start C? No? It scared you off? Okay. So f of x equals 16x cubed. Easy enough, right? The trick is that our interval is from A to C. Not to be confused with A to B, right? But it's the idea of A to C in place of A and B, but then B is C, right? They're just the 2 pieces you're plugging in. That's what it comes down to. So, officially, not that it really has to be written down a whole lot, that means we need to find f of A and f of C. Yeah. Okay, so they give us A and C, so that's where we're fine. What is f of A? 16a to the third, because every place I see an x, I replace it with A. So 16a to the third. Okay, what is f of C? Yes, I replace it with C. Okay, so what's your basic setup here? So we say f of b minus f of a, so we're going to do f of c minus f of a, so it's going to be 16c cubed minus 16a cubed over, instead of b minus a, it's going to be c minus a. Am I done? Not exactly. We're not going to cancel anything right now, but there's some factoring that can happen. Okay, so note right here, in this form, can I cancel C's and A's? And the answer is no, because in order to cancel C's and A's, you can't just cancel AC or an A, because they are part of subtraction problems. The denominator is the quantity C minus A. If that numerator has a factor C minus A, then we can cancel the factor that numerator. Now, start with the obvious factoring in the numerator. What do you see? A GCF of 16, yes? Everyone can handle that. Okay, so let me factor out the GCF of 16. So then I have 16 times the quantity, C cubed minus A cubed. Carrying over the denominator, C minus A. Okay, C cubed minus A cubed. Do we remember anything about how to factor that? No. I'm 99% sure we've done it this year. Might have even come up in that. I'm thinking it was in a chapter P towards the beginning, but I don't remember exactly. Unless I'm confusing my pre-calc and calc. Do you remember how to factor? This is kind of a rhetorical question, so I'm not expecting the answer to be yes. The sum and difference of cubes. But I don't remember where. And I'm not finding it I'm not finding it right now. So maybe I've only reviewed it in calc. Maybe we haven't talked about it in pre-calc yet. Okay. Sum and difference of cubes. C cubed minus A cubed. It's the difference, right? Because it's subtraction. C cubed is a perfect cubed. A cubed is a perfect cube, correct? So that's why this falls into the category of difference of cubes. The 16, I'm going to leave out front. Now, when we factor a difference of cubes, what it does is it factors into a binomial times a trinomial. I don't know if this seems familiar at all or not, but it factors into a binomial times a trinomial. The binomial is just the cube roots keeping the sign the same. So what is the cube root of C cubed? C. It's a subtraction sign in the original problem, so it continues to be a subtraction sign in the binomial. What is the cube root of A cubed? A. That's the binomial, so that's the two terms. The next part is a trinomial. And this one, the first term, you take which cube root is, and you square it. So I'm going to take C, and I'm going to square it, and that becomes C squared. My next sign is always opposite the original sign. So since the original sign was a minus, we're going to have a plus. And now for this middle term, you multiply the two cube roots. So we had a cube root of C and a cube root of A. So we're going to multiply C times A, which is CA, or I prefer to say AC, just because I go alphabetical. And then the last term is similar to the first term there, where it's the other cube root squared. So my other cube root was A, and when we square that, it's going to be A squared, and it's always adding at the end. So plus A squared. Okay? Does that sound at least a bit familiar, or is...
Yeah, seems pretty foreign.
Okay.
looking at it though, I definitely feel like we've seen it at some point.
I feel like, I don't know, I feel like maybe it's come up once this year in something, maybe not. I feel like maybe it came up a teeny bit in Algebra 2, maybe not. I can't remember where it first gets introduced. Maybe this is it. Maybe that was your introduction. I really don't remember.
It's like the canceling thing.
Yeah.
Because it does look.
Okay, well that, and I will take you through, every time I factor a sum or difference of cubes, I will take you through that process. Okay, so just, you know, I feel like it will be in home. I feel like there is an example in 78 that involves this. Towards the end of 78, but I feel like there is. Point of that, what just happened?
Cancel.
A factor of C minus A can cancel with C minus A.
Is it designed to do that like the other?
I think so. Question being, is it designed to do that? We'll do that every time. It was designed to do that here. And it depends on what your original function is. How's that for an answer? Okay. So what remains for my final answer?
16 times the quantity C squared equals 18 equals 8 squared.
Okay. 6. Okay. So that's kind of the other, you know, A was pretty easy. B was pretty easy, right? C is on the opposite end of that spectrum. It's the factoring that you have to work on there. Okay? So I will say difference of cubes. That may have been the first time I showed it. Okay? But it will not be the last. So don't think, I don't have to ever worry about learning that. Do worry about, you know, getting it figured out over time. Okay? Questions on average rate of change. Got the basics? As long as I don't throw too many of those at you. Okay. You can handle A's and B's. The C, you could. Now, valid point. Could you at least set up C? Yes. You could at least factor out GCF of 16. Yes. And it might stop there. Okay. But
I'll just remember the one we're always
but you still have to figure out what the other one is. So work to figure that out. Okay. One other thing I want to talk about that goes with this part 1 of homework, and that is linear correlation. And I asked you to bring your calculators because our calculators can do some of this for us. Okay, so hopefully you have your calculator with you. You guys have done linear correlation. This is not a new topic at all. Positive, negative, no correlation. You guys have been doing that since Algebra 1 or before. Okay, so we're going to add in the twist of what the calculator can do for us. So, okay, so when we graph tables of data using our stat plots, remember we learned how to graph dots on your calculator, right? And points. We can tell whether or not the dots are clustered along the line. If they are, we say there is a linear correlation. If the line has a positive slope, so going up, so that means moving down to the right, there's a negative correlation. And then it's also possible for graphs to have little to no linear correlation, where the dots are just, the points are scattered. You guys see the examples here, yes? I'm not sure how much you need me on this, but example A is a positive correlation. Now, I'm going to call this example B, but the second example is also positive, it's just not as strong, yes? Okay, then we get one in the middle. I would call that no correlation. They say little or no correlation. Okay, and then these last two, can you see the negative correlation there? That's all right. Basic review. Old news. Okay?
I feel like the reason they say little is because the top dots are kind of starting to go up. I think that's why it says little. Yeah.
Okay.
That's probably the only reason why.
Yeah.
You can look at it so many different ways.
Yeah. Okay, example 4. We are given a table of weekly sales data based on market research for prices of boxes of a certain breakfast cereal and the number of boxes sold. Describe the strength and direction of the linear correlation. Then write a linear model for the demand as a function of the price of the box. Use the model to predict weekly cereal sales if the price dropped to 2 they want us to do here. Now, the first thing they want, describe the strength and direction of the linear correlation. Which means, I want to know, basically is this positive or negative, right? You can add in strong or weak. In Algebra 1 and Algebra 2, you made a graph by hand, yes? We have our fancy dancy calculators. Okay, so you have to enter this information on your calculator, right? So I'll get you there on the calculator here in a moment. I was going to say, now the question is, does anyone have any clue how to get there? Okay, so yes, I agree. You click stat, which stat is right there, 2 over from alpha, just to the left of your arrow pad. It brings up this screen that you can't see. There we go. Edit, calc, and test. Most of the time when we're entering data, I just hit enter right here on edit. And it brings up my columns. I already have data from whatever I like. Easiest way for me to clear the column, not delete the column, is to go up to the heading and hit clear, enter. Clear, enter. Or you can delete individual entries. Stat.
Which one did you go on first?
Edit.
Sorry, I was...
Can't space off right now. Are you on the right screen?
Yeah, I am now.
Okay. You got your columns cleared.
Yeah, they're cleared. I didn't have anything.
Okay. Start entering your data, yes? I can't do that for you. 2.4, 2.6, yada, yada, yada. I'm going to be quiet so you guys can think on your own. A good check when you get to the end is, are your columns the same length? That's always a good check. You know. So get that information entered. Then we need to go look at the graph, yes? So you need to turn your stat plots on. I'm debating which way I want you to do this. Honestly, what you can do, you can go into your y equals screen. This is not the way I originally showed you. You see where it says plot 1, plot 2, plot 3 up there? You can just go up to plot 1 and hit enter. And now notice my plot 1 is highlighted. So my plot 1 is on. The way I originally showed you, though, is to do a second y equals, and it takes you into this screen. So like my plot 1 is L1 and L2 automatically. If you need to change those and make it like L1 and L3 or something like that, this is where you would go. Does that sound familiar? Okay, now, if I go ahead and go to graph, notice I don't have any dots on my screen. Why do I not have dots on my screen? It's not in the right range, yes? My X values are good, but what kind of Y values did we enter? Really large ones. So, this is where I'm not even going to try a zoom because it's going to be crazy. I'm going to do window, okay? And as we do window right here, I would change those window settings. As we change those window settings, how low and high do you want to go? How low and high do you guys want to go?
So the low could be like, a bit like 40. Yeah.
Well, can we change? We can change X's, yes?
Yeah.
Mm-hmm.
My X is 2.4 to 3.6. I'm going to try 0 to 5. I don't know how I'm going to like that, but my X's, I'm on 0 to 5. I'm on my window screen. 0 to 5. Y's, I'm not going to start at 0.
The minimum you could do is like 17,000 or 18,000.
You could do 18,200.
You could do 18,200. I was going to go 18,000. you'll be in the right area. Okay, and then we need to go, what, up to above 38, right? Above 38,320. So I'm going to say 39. I heard 40. You could go 38.5. If I don't like it, I can come back and change it, yes? Now hit graph. I have dots. Now, if you use slightly different window settings, your dots are going to look slightly different, yes?
Wait, do you have little like lines at the bottom of the graph?
Like little kind of tick marks?
Yeah.
Yes.
Okay. What is that supposed to be? I don't know.
That's my 0, 1, 2, 3, 4, 5.
Okay, it is okay.
Yep.
It's hard to tell. It just looks weird.
Yeah. Well, and that's because we're not really showing the x-axis. That's the key.
Yeah.
And since we're not showing the x-axis,
that's why there's not a line. Because it
Right.
It show. Okay, that makes sense.
yeah. Okay, so all of that too. Describe the strength and direction of the linear correlation.
Strong negative.
Strong negative?
Strong negative.
Okay. Which, could you kind of tell that by looking at the data?
Yeah.
I mean, you could tell negative at least by looking at the data. But we have, we're going to have to do this anyways. So,
It's also going down by thousands.
strong negative is my first answer. Okay.
Linear correlation.
You can. It doesn't matter. You can. Okay. Part B, if you want, is going to be to write a linear model for the demand as a function of the price of the box. Linear model means we want an equation in what form? Like what? Slope intercept, y equals mx plus b, yes?
Yeah.
Now, we could pick two dots. We could find the slope by hand. Okay. We can use those two dots to then find our b value. And we can write this by hand just like we did yesterday on the front side of these notes. Or calculator. You knew that was coming, right? Okay, so I will write down the steps here in a moment, but I'm going to take you through it on the calculator. So first thing, go back to stat. Your screen look like this?
I have a huge. It's so hard to see. Because I have a huge graph where I am. That's why I dropped my calculator. Just like.
If I
If you move it down more, it'd be better.
Does that help some?
Yeah.
Okay. So stat. We got that, right? Now this time, instead of just hitting enter and going into edit, arrow over to calc. Start scanning that menu. What do you see? Linreg, linear regression. Notice what form it says. AX plus B. Okay, so I'm going to go down to number 4, and I'm going to hit enter. Now, where's my data at? L1 and L2. Is that what this says?
Yes.
Okay, so I'm in L1 and L2. That's good. Go down to calculate and hit enter.
Oh, that's so fun.
It just tells us.
Now, exactly, it just tells you. Or was this in Algebra 1, right?
Yeah.
Okay, so now, notice it doesn't just flat out say the equation, but you can figure out what they're meaning there. It says y equals ax plus b. They're telling you a is negative 15,358.92857. They're telling you b is 73,622.5. Think about it. B is your y-intercept. Does that make sense? It's bigger than all your other numbers, right? Which it should be. It gave me a as a negative slope. That makes sense, right? Okay. So, I'm going to write down some information here. First of all, over to the side, I'm going to write down the steps we just took. So I went into the stat menu, and I arrowed over to calc. Then I went down to number 4, which is linear regression, AX plus B. And then I went to calculate. Those were my steps. You write down the steps however you want, but I'm just trying to get you, like, what buttons did we hit on the calculator? Okay? I'm going to write down my answer here. Y equals negative 15,358.92857 x plus 73,622.5. Now that is non-rounded. What do I have written in here? Looks like for my final answer, I rounded it to 2 decimal places. Honestly, you could leave the whole thing. You've got a calculator that you can use for the next step, or you can round it. So I wrote it as negative 15,358 93/100 x plus 73,622 and 5/10. And that is my linear model that the calculator was so helpful in doing for me.
I wish I knew this in like algebra too.
So is there any benefit to not letting us know about this technology?
We didn't.
I can't ask Algebra 1 students to spend $100 on a calculator.
Oh, you should have. I would have done it.
I mean, you know.
You told me it would have given me my answers on the test.
I mean, if they're going to use it,
No.
they calc anyway.
All the time.
I would have been robbed today.
Okay.
If you could tell me that I could solve all of my problems, that's simply the
Okay. We got one last part of this problem. Use the model to predict weekly cereal sales if the price dropped to $2 or raised to $4 per box. What do we need to do?
You just plug those in for X.
Plug those in for X? Okay, so one option is to plug them into X. Meaning, and now, I mean, really, I'm just writing these out. So, on the first one, if we use X equals 2, then you're doing Y equals negative 15,358.93
Why is X equal to?
times 2, because it says the price dropped to $2 a box,
Honestly, then we're going to use 45.
plus 73,622.5. You can. I mean, there's nothing official that we ever define this as F, but I get it. Okay. So, you plug that in. Do the calculator. I have written down that the calculator gives me, has anyone done this? Okay, I won't say it out loud yet.
Oh.
Okay, I did it. Oh, you already wrote it. But I didn't say it out loud because I wanted you guys to figure it out. 42,904.64
Why did you draw another equals to?
because I'm getting ready to round it.
Oh,
Are you going to tell me you're going to have 42,904.64 cereal boxes?
Oh, mine is 0.72. Does that matter? Mine is 0.72.
Did you use the 0.93 rounded version?
Yeah. Oh, I put 3.9.
Okay, there's your problem. That's why you're close, but not quite. I have written in my notes approximately 42,900 boxes.
wait, why not the 4?
It's an estimation. Okay?
Oh,
Because it's used the model to predict weekly cereal sales. Is this going to be exact? No, it's a linear regression line. It's a, line of best fits.
So
Is it
yeah.
precise? No, it's an estimation. It's a prediction.
So if we did put 904, you wouldn't count us wrong.
No.
Okay.
No.
Okay.
And then you can do the same thing with 4, yes? Yes. I will write down what I have. You check yours. Now, and honestly, you guys know how to kind of copy and paste on your calculator?
No.
Because okay, so there's always more. Okay, So if I had typed that in on my calculator the first time, yes? It was a lot of numbers to type in, but I don't want to have to retype the whole thing. The only thing I need to change is what? The 2 needs to become a 4. So, do you guys realize you can arrow up? It's highlighted. I hit enter. And then I can just arrow back over and change that 2 to a 4. And hit enter again.
Wow. That's a nice one. I don't remember that.
I'm sorry.
Had a calculus.
Hey,
Algebra 1 could have been 10 times easier.
Okay.
Algebra 1 wasn't really hard to figure.
It was with Miss Brown. Okay. Now, I've got one other option of how you could have done this. I'm going to go to my y equals. You know we came up with this equation, yes?
You rounded it to.
I'm going to put in my equation, negative 15,358.93x plus 73,622.5. That's the equation the calculator gave me, yes? When I graph, what should this line be doing? Running right through those dots, yes? Because it's a trend line, and it's based on the data from those dots. Here's one other option of what you could have done. I just put that equation in. I can substitute an x value in there. By either, first of all, I could hit trace, and I could hit 2. What did it just do? That's not what it was supposed to do. Trace. Oh, okay, it's on the... Once I hit trace, I have to get it so my equation is showing up here. And then I could hit 2. Notice it says x equals 2. And it gives me the output of that y value. Okay, I could hit trace again. It put me on the stupid equation, so I'm going to arrow down to get to the y1. I can hit 4. And it gives me that right there.
Wait, is that, I can't see it, but is that the y equals?
Yes.
The x, the 2 x's?
Yes. It's the same y equals that we had found.
Did you round it to
Wait, what is the?
190.
190?
Okay. So, the other way is if you use second calc, value right here, and if I hit 2, that's the same thing if it's doing the trace. And so if I go into our second calc menu, where our 0, min, and max are, and value, it says x equals blank. So if I type in 4, it gives me that 12,186.78. Okay? No different than typing it into your calculator screen, though, right? So, probably. I was debating, should I write the step for that or not? Okay, I'm going to say can substitute x value into equation, or can trace line and enter value.
On the stat thing, how do you put all?
Just a second, I'll hold that. Okay, if you have not written down the homework, I want to get this real quick, if nothing else, for my online. The homework that goes with this is page 169. 2 through 12 evens. 53, 68, 78. And, oh, dang it. Okay. Gosh darn it. Struggling. Oh, I left out 45 through 48. 68, 78. That is what goes with this homework that you were supposed to be doing. My apologies. I will tell you, 7 through 12, I don't remember what you're doing, but it says at the end, do this and then graph. Don't graph.
Oh, I didn't.
You didn't. So I think you write the equation of the line. So just write the equation of the line, but then don't graph.
Well, I started it last night, and I noticed that the person who had the book last year crossed it out. So
Okay.
I was like, okay, I probably shouldn't do that.
And that's usually a good indication if it's crossed out in the directions. It's likely that I won't be